Okay, I'm going to start first a little formal, but then I'm going to have a seat because this is going to be a great conversation. I think it'll be a lot of fun too. Okay, so first I'm just going to have a little talk. The question and the name of the panel is, will it deliver on its promise to finance? Did AI promise? Or isn't it more along the lines of, if we can make it deliver, then cha-ching, right? There continues to be an effort to read the bushels of tea leaves of big data and convert that information into confirmable and therefore actionable investment and trading ideas, and more importantly, the implementation of the revelations of the increasingly complex strategy designs that A1 will permit. I said A1, I mean AI, look at that. AI is expected to play this lead role within the structure. I myself had managed and run an algorithmic strategy where my associate and I designed in the simplest form compared to the opportunities of AI and its potential to manage bigger data sets, capture the esoterics of emotion in text across research and other media that we could never capture. The most interesting strength of AI is just that, reading the numerous cues in tandem with the hard data and concomitantly increasing the success in sourcing liquidity to get the trade done, while somehow being able to manage through black swan type events. We can, to an extent, compare it to complex event processing and its ability to negate extraneous non-correlated data. But it is so much more than that. Now I'd like to introduce the panelists. Okay, so let's start. I'll start down the line. Let's start with Rahul. Please introduce yourself.
Rahul Jaising. I head up a business at Barclays called Quantitative Prime Services, primarily focused on systematic managers. We provide execution, financing, prime brokerage, and capital introduction services.
Stuart Hall. Stuart Farr, excuse me.
Stuart Farr, president of Deltix. We are a software company, 60-odd person software company, and we have a platform that's been around 10 years or so now that allows quantitative systematic managers to express their idea, backtest their idea, optimize their idea, and ultimately to trade it.
And Gordon Ritter.
Hi. So I was a mathematical physicist in a former life. Been on the buy side for about 8 years now, my entire career. So I was at Highbridge Capital for 7 years in the Stat Arb group there, and currently run the New York office for a quantitative hedge fund known as GSA Capital.
Okay, so just a quick note about a little bit about my background. So we mentioned lead project manager and business analyst of e-trading and cash trading and technologies for Gravitas Technologies. I'm currently at Evercore, helping them with some interesting topics there. A little bit about my background is I was at Millennium Partners for a number of years, built a trading desk there back in '97, and started what we didn't know what it was called, but it was a high-frequency strategy. We just knew that it was damn fast and we were beating everybody else out with all the data and information we were able to collect and how fast we were able to collect it. Now, everything that's happened today, well, we're eons beyond what I was doing, and the technology is way beyond that. And that's why this topic on AI has been so intriguing to me, and I'm sure it will be to you as we continue this conversation. So I'm going to grab a seat and we'll start talking. There we go. Okay. So I was talking a bit with Stuart the other day, and we were talking about use cases for AI. So some of the topics were alpha generation, genetic optimization, et cetera. And I'd like, Stuart, I'd like to grab your thoughts and let them hear what you had to say. It was really interesting to me.
Thank you. Well, first of all, just on the alpha generation side, I think the example I quoted is that one of our clients that we had, and that sort of tells you the end of the story, was very successful using genetic optimization techniques to develop trading strategies in FX that were predicated or based on 20 very simple, normal technical-based strategies. That those of you who've done this will immediately recognize various Bollinger Bands and very simple technical indicator-based strategies. They had 20 of those, and then they used genetic optimization to essentially test millions of combinations of these in combinations with themselves and parameterized many, many times, millions in fact. And as a result of those, they ranked these thousands of strategies and traded the top 10 for the next 5 days. They did this in the context of a bank and was extremely successful. very successful, did very well. They were so successful, in fact, that they said, "Look, we're going to do this on our own." So they spun out, they formed a hedge fund and did the same thing. And those of you who work in banks will sort of understand this next statement. The profitability in the bank was very good, but they didn't look at it too closely. When they were in a hedge fund, the investors looked at it very closely, and they noticed, unsurprisingly to us, that the P&L was very, very good until it was very, very bad. In other words, there were massive drawdowns alongside massive returns, which overall the returns were very good, but the hedge fund ultimately closed down because that volatility was so tough. And critically, and this is the sort of philosophical point, is that because it was genetic optimization, the managers couldn't say why they were doing these trades. We were just saying we're doing these trades because AI tells us to do them. And it works when it does, and it doesn't when it doesn't, but we can't explain why. So the takeaway for us from that is it can work in the right environment, but you can't explain why in some cases. In this case, they couldn't.
Interesting. So, I guess we'll also take you to the next level. Now, I come from the trading side, and I look at it at the way PM might want to implement their strategy. So when I take a look, I'm thinking about how am I going to get that order executed? I look at how advanced is the algorithm that's going out to the market that's going to get that executed. So looking at that, we also talked a little bit about adaptive execution algos. And I also want to hear your opinions, if Rahul, if you want to jump in on that.
Sure. So first of all, just a compliance disclaimer, any views I share are my views and not the views of the company I represent over here. I want to get that out of the way, first of all. But I think that where this is starting to become very interesting, again, especially in the quantitative segment that sort of we cater to, is as market microstructure has become very complicated and globalized as such, I think that sort of being able to get data sources of various nature, drawing it down to its most granular form and getting predictive analytics on the base of that data is an interesting subject overall, right? And the community at large, from the managers to the banks to execution algo providers, are all sort of toying in this field where how they optimize execution through predictive analytics is becoming a big area of research as well as technology innovation.
So there's several pieces of that, which is also, it's the technology and access, et cetera. There's the microstructure and, of course, the macrostructure, depending on if you're using a particular algo through a broker, et cetera, and what their reasoning is for what markets they're going after, et cetera. I guess a good person to ask you is Gordon on the desk, and the strategy you're using, and how are you going out to the market, or how do you perceive that will change?
In terms of execution specifically?
Well, you could take it towards designing strategy as well.
Yeah, I mean, so I love AI. I mean, and it does so many things so well. I think the key thing is to sort of understand what it's likely to do well, and what it's likely to do poorly. So an example I love is recognizing handwritten zip codes on envelopes, right? So AI can do that with something like 99.9% accuracy. So it's fantastic, right? It's great. If we were going to, let's say we were going to build a mortgage pricing model and zip code was an input to the mortgage pricing model, and we somehow had to parse the zip codes ourselves, would we want to use AI? Absolutely. I mean, we'd be crazy not to. So there are other things maybe that it shouldn't be expected to do particularly well on, right? And those are cases where the signal to noise ratio is particularly bad. And so, I mean, we live in an age of big data in finance, and when I look out there are all these huge data sets, some of the largest of all being tick data, but other data as well on anything you want from weather patterns to to news, intraday news feeds, to credit information, et cetera. The vast majority of that data is in fact noise, and a tiny little bit of it is signal. A lot of AI-based algorithms are kind of designed around, there is a solution, like a robot navigating through a room. It's known there's a room. The zip code parsing. I mean, generally, almost all envelopes have a zip code of some sort, right? So, Yeah, I think there's, it's still a great challenge for AI in the sort of very, very low signal to noise regime.
Well, actually, it touches on something that we were discussing also. There is obviously a plethora of data out there, and it is deciphering through the noise and finding that signal, which is most likely going to be a weak signal, that's going to help you decide what you're going to do next. Right? So we continue our conversation. We got off topic a little bit, but it's interesting. We're talking about self-driving cars, which seems to be a topic quite a bit in the news anytime you put on Google or something. And how do you get that? There is a set or a finite data set to having a car drive, right? And whether you see a cat in the road or maybe it's just a plastic bag floating, you just know it's an object and the car could do something. But when you're in a strategy and you have this fire hose of information coming at you, and you need to be able to decipher if something within that is going to make a difference in your strategy, that's the difficult part, right? So I guess some of the question is, how do you I know you know the answer, or not, there is not a total answer, but defining your data set, that's the difficult part. Let me ask Stuart that question, and then we'll go back.
How do you define basically, you have to try. You have to do it. You have to try it. You have to do research on it, and that takes time as well as tools. You need to be able to. You can't see the value unless you've tried it, I guess. And there are firms that do that for a living. Well, not quite for a living, but they spend massive amounts of resources on looking at some of these data sets Gordon touched on. That's what they do. They go out and collect them and analyze them, and they don't know if they're any good until they've analyzed them, and doubtless the vast majority of them aren't. But you don't know that until you've done it. So I don't see, maybe that would be a good AI, actually a macro AI application, is to do that somewhat less intensively human-wise. But at the moment, it's a human-intensive process.
It reminds me of something when big data came out, and that was the touch point or the word of the week, I guess, way back a couple of years ago. Someone asked me, I was at another panel, and someone in the audience asked me, well, what is big data? And I asked if anybody had kids in the room. I got a few hands, went up in the air, and I said, well, imagine this. And you might smile if you have children, but just take a big bag of Legos and drop them on the floor and say, okay, make me a dinosaur. Well, you have to figure out what parts are relevant to that dinosaur. So in doing that, the next process is, well, how do we get there? Is there a blueprint? Well, we don't really have a blueprint. We have a general idea of what information might be relevant to what we're doing. But if let's say you're trading commodities and you have to analyze weather patterns, because that's going to make a difference in the cost of whatever you're going to buy, not now, but your futures they're going to vacillate based on that. Mm-hmm. So I guess, to some extent, I'd like to ask Rahul a few questions. I introduced another item that would pop in here, but we also have these black swan events. So there's tornadoes going on. How's that going to affect commodities? So maybe you want to just touch upon the importance of how to manage.
Yeah, I think that's sort of just, extending from the point Stuart was making. I think while you have a number of these different data sources, I think where AI starts to become more relevant is how do you possibly sort of bring in the concept of creating data models that are self-learning in the way that both the inputs and the outputs sort of with dynamism sort of continue to grow, right? So when you look at risk events that aren't predictable, we all know black swan events happen. We know risk events will happen. The question is, what are the different data inputs that possibly can help predict or have a view into what the probability of different output situations are for different type of risk events, right? And I think this is where constant learning is going to be a stream of research, but from a machine learning perspective, and even in the, what I find fascinating is as you start thinking about the uncorrelated data sources, but the vast majority of them, how do you bring in those data sources and start drawing correlation, which is difficult to kind of normally think about through human context, right? I think that's where the machine processing will start to come in.
Yeah, and I guess the next thing is something that I touched upon with Gordon was, he asked me, he goes, well, how hard is the problem that you're trying to solve? And I thought maybe you want to make some comments on, and that pretense and understanding how you make the decisions on what you're looking, perhaps.
Yeah, so I think AI will be extremely useful in certain specific ways for asset managers like me, right? So I view my job as essentially to try to understand what really drives stock returns. So perhaps AI can help us understand that, right? So I mean, in that sense, AI that's kind of uninterpretable, right? Like, the example of something that drove a trading signal, but you had no idea, why, or you couldn't explain what the machine was doing. I find that, not so useful, and frankly, kind of scary, and frankly, possibly the cause of, the next black swan event. But I mean, to the extent that AI helps us actually understand what really drives asset returns, then it's great, right? Often that kind of has to start with a human prior. So I mean, I think a great example was, we had a great talk by Peter earlier today where, he didn't put it in this language, but clearly sort of began with a prior that earnings are probably quite significant in understanding the cross-section of equity returns. But exactly how and exactly what sort of relationship of that general form is built into the news. You could call it regression, or you could call it a simple form of a neural network. But AI is essentially explaining to us exactly what that relationship is. But we had a strong prior.
Okay, so then I guess that leads me to another thought is actually something I talked about with Stuart, was what are the prerequisites for AI? And we could take that to many different levels, from the technology to the data sets. But.
Well, I'm going to answer that question just with a preface. So just under 25 years ago, I did a master's degree in artificial intelligence for the prime reason that was going to be the big thing. This is 22 years ago. AI was going to be the next big wave in finance, and particularly neural networks to that point. And as we're having this discussion now 20 plus years on, so I take away from that, don't take anything I say predictive-wise as being very, very value. But to answer your question, I think one of the reasons it didn't really take off back then was the prerequisite really is to analyze data very quickly, a lot of data very quickly. And the computing horsepower the computing horsepower that's changed in the last 5 years, let alone any further, means that you can, and because you have to, process a lot of data very quickly. And you're either processing a lot of data very quickly because you've got terabytes to work through, or you need to do it in real time, drinking from the fire hose in terms of market data. And that ability to process data very quickly, I think, is the reason, or a major reason, why AI has taken a long time to really, and still is, taking a while to get established. It's the ability, is that simple, not simple, the simple concept to process a lot of data very quickly.
And maybe to just add to the point over here, sort of with computational power growing, I think what's also happened over time is that data sets have grown just naturally. We've had a lot more data sources available now than they were 20 years back, but so has ability to sort of store and access that data, right? So storage is a big part of what AI is all about. So while you have the computational power, I think the concept of the innovations in micro technology has actually made storage a lot more affordable and easier, and I think that's contributing and fueling the growth of AI overall.
So what we have to look for really is it's the technology to be able to absorb it, have the data center and the storage to be able to hold on to that data. I think some issues what I had when I was working on my strategy was we were able to backtest up to 2007 or 2008, I guess, when everything happened. You can't really backtest so much, but with AI, you might be able to actually take that information and understand where you're going to go with it in the future, I guess. You know what? Actually, I'd like to see if you have any questions in the audience, because I think it'll be greatly added. If someone could bring him a mic over there. Thanks. I mean, you could, if you want to say it, I'm sure. I'll repeat it.
So I think you said it rightly that wherever the signal to noise ratio is higher, maybe AI can do a good job. What about ensemble models, which work on the principle that we can have very weak predictors and combine them and get something good out of them? Yeah,
I mean, I agree. I mean, I think it's still the case that the signal-to-noise ratio of a combination of weak predictors in finance is going to be way, way less than the signal-to-noise ratio of like a cat in a digital image or something, right? So, or other cases where neural networks have been extremely, and other forms of deep learning have been extremely successful. But yes, combining a large number of weak predictors can certainly yield a much stronger predictor, and it's typically not obvious to humans, or not really within the typical human skill set to, oh, RavenPack gives me 2,000 categories. Clearly the 2,000 dimensional weight vector is this, right? I mean, that isn't something you're going to sort of write down with your intuition. You may be able to come up with a prior for it, but.
One more question, then we'll continue.
I guess this is for anybody up there. Do you think that the issue around implementing AI in your research process is a research process design issue, or is it an inherent attribute of what AI is doing relative to the historical kind of quant research process, which looks at an in-sample set, then looks at an out-of-sample set, compares them, and you kind of see whether you've got something there. AI doesn't do that inherently. It's running a completely different process, and so it's very hard to understand whether what you found in this sample is going to happen in that sample. Is it a research design problem, or is it an inherent property of what it's actually doing?
I think it's actually philosophical. So the example I quoted earlier about the fund who was doing exactly that, he had this thing that worked until it didn't. But he couldn't explain why. No idea why this combination of very simple technical strategies parameterized thus did a 20% return and then did -10. They couldn't explain it. So I don't think that's an inherent property of the technique of using AI, but you either agree with that approach or you don't, which is why I say I think it's more philosophical. It's without question, you can't explain it, so that's a fact. Whether you agree with it, I think philosophical, that's my take.
One more question?
Just 2 quick points that I would like for clarification to hear your points of view on this. Firstly, isn't AI just a convenient way to get into the boardroom, so to speak? Quantitative methods that typically have the CEO scared, but using some terminology, we'll call it AI for lack of anything else, where we're just going to be using all the tools that we've had and new ones that have been developed, and we're going to categorize them and use them because they're going to finally let us. And that's the first part. And the next part is you have to be very careful with analogies because there are plenty of black swans in Australia, for example, that's from your vantage point.
Well, to answer the first question, let's discuss a little bit the difference about deep learning, machine learning. We hear all these terms that are going around, real-time learning, et cetera. Let's talk a little bit about that first. And I guess let's start down the line with Gordon about what are your thoughts on how would you define deep learning versus machine learning?
Yeah, that's a great question. So I typically think of sort of statistical learning parameters where you're examining the parameters and you have some idea what they are. So let's say you have three predictors. One is price to earnings, one's price to book, and one's momentum or something like that, right? And then you're interested in what sort of parameters to put on those predictors. You're still examining the parameters, and it's a statistical inference problem. You may have a parameter prior, you may not, and ultimately you get some information about the parameters, and you understand that information. You can say, it's telling me to put more weight on value or something, right? Versus, I want to contrast that with deep learning where there's typically there are parameters, but the parameters are either hidden or far too numerous, and or the structure is far too complex for humans to sort of get much out of it, right? So coming back to the problem of like recognizing handwriting or speech or something like that. Nobody is sort of like trying to understand what exactly the weights on the neurons internal to the two-layer neural network are actually doing. They're mainly simply concerned with, its performance, right? And the performance is quite easy to measure because there's no shortage of postal codes and voice samples to look at. And so that's why they can be safe with not really even knowing how many parameters are in the model or how they're interacting, right? And the latter type of problem is often one where, humans would be great at it, right? Versus, kind of statistical inference with multi-parameter models. Humans are horrible at that.
Okay, and so Rahul, you want to?
Yeah, I think that sort of maybe another way to kind of think about the problem is that, when you look at applications of what has been considered to be deep learning, image recognition as an example, it's very easy for the human mind to sort of have a perception utility around detection of certain things within images, right? If you're observing for an animal within an image, whether the animal is a cat or a dog is very easy for a human to perceive. I think in an AI context, the question is, how much knowledge is inputted into the system to sort of make that detection a classification-oriented detection, right? So I think that's sort of where deep learning has grown as a field is in these subjects around natural language processing, image recognition, etc., to categorize and infer based on human perception.
I think just to note, then I want to go to Stuart. Is just I don't know if anybody's ever called or used a chatbot on let's say maybe one of the companies you do business with, like a billing service or something like that, and you type in information and it comes back to you. That is AI. That's coming back to you. That's not a person talking to you. It's just looking for cues in your conversation. So that's the interesting part about it. It's that either it goes by a set of rules, but the next part is it's learning from its past errors or past mistakes. Stuart, I'd like to hear what you have to say.
Well, just as a data point, we deal with quantitative managers, a lot of them. So we don't have anybody or have had anyone, I think I'm right in saying, who has used or does use deep learning. Just as a data point, take that for what it may or may not mean. But we do have, to Gordon's point, we do have a lot of people who use AI techniques to help them in a well-defined domain, which is complex, but you understand what it's doing. It's techniques to help you search out factors or parameterization for those factors. So to make that distinction, deep learning, no, if you will, and AI techniques in a well-known domain, yes.
I guess in that response, AI has the ability to adapt, which I think is key.
Yeah, so we this is sort of early stages, but just to bring that back down to trading in general and execution, whether you're doing systematic or not, and using algos, which is nothing new there in terms of VWAPs and TWAPs, been around a long time, not much new, but people have talked about, and AI is starting to be used to help change an execution algo in flight. So somebody has presumably, and that's another story, but somebody's presumably chosen to use a VWAP or a TWAP parameterized like this to get out of this Apple position. So normal use case. But the reason that they may have chosen that algo and that parameterization may be inconsistent now because the market has done something the state is not where it was supposed to be for that initial decision. So having that to adapt in flight, in other words, changing the parameterization dynamically, is something that some of our clients are just starting to use some AI techniques on. And we've demonstrated, and it's fairly easy to do, is that the potential savings improving very small numbers of basis points on very large positions adds up very quickly. So they have real incentive to do this. And I think it has a lot of potential to be very cost effective for them.
Okay, honestly, I think I'm enjoying the questions from the audience because you're coming up with some great points here. Does someone else have another question? No? Okay, when you think of one, put your hand up. We got on the side there.
Hello. Do you see your AI as a tool to replace the humans? Basically, as a trader, you'll be looking for something, right? But if you're looking for a strategy you're thinking is good or bad, AI is going to do it much faster for you, right?
Personally, I think it's more of a toddler at this stage, but a toddler that reacts to situations, et cetera, that can respond. I think, you look at, I'm going to talk a little bit about the end let's say like Asimov and his determination of what AI is and how to protect yourself from it, et cetera. But I guess some of the important things is the pragmatic use of AI, because you want it to solve a problem, and you have to be able, as you mentioned, to explain why it got to the answer that it did. And if you want to just elaborate.
Yeah, I mean, the applications of AI are quite well known at this stage. I mean, even in the financial services space, I mean, we're looking at AI very, very extensively used in the fraud detection business in credit cards. We are looking at it quite extensively used in execution algorithms right now, similar to the points that have just been made, in sort of getting more real time in looking at not only market data, but sort of also the performance of the expected outcomes of those trading opportunities. So I think the AI applications are quite well known at this stage, and I think it's only going to continue to grow.
Yes. Stuart, did you want to answer to that?
Well, just something Rahul touched on. So on detecting bad behavior, we're sponsored by somebody to help them look for bad behavior, particularly front running. And we've used some techniques to do that, which have got interesting results. I mean, nobody's gone to jail yet, but we've got some interesting results from using SVM techniques to look for those patterns.
SVM?
Support vector method.
Okay.
Techniques. So yeah, that's again interesting, but different purpose.
And we have another question right up front here.
Hi. Well, I think this gentleman was talking about this, when we reach the singularity, will we need people? And I think by definition, it's no. So,
right.
But until then, I guess we do need people. My question is, in terms of where we are as a toddler with AI, what is the role and the intersection of metadata, and not just simple metadata, but metadata-driven behavior? Have you had any experience with that, and where do you see that going in the future?
Would you like to take that, or?
What do you mean by metadata? I mean, I know what it means, but what do you mean? Different sorts of data?
Yeah, and I'm not talking about it's got a particular type of string or something like that. I'm talking about information that's used to drive system behavior.
Okay.
And so how does AI interact with that, or you can generate its own metadata? Are you seeing any applications for that, or is that still not work for a toddler?
Well, it certainly has to be aware of, at least to understand what the outliers, something that is an outlier, I assume, or something that's more extraneous to the goal at hand, I suppose.
Well, that would strike me more as a parameter than metadata.
That's true.
I'll give you one example. Whether you class this as metadata, you can determine that. But we looked at some regular earnings data which has been around forever. It's the old school earnings data. In other words, crowded analyst predictions in the old school method. But we looked at it not in that earnings number itself, but the date upon which that earnings was announced to be made when that changed. So something way below the radar nobody cares about, or turns out there's some real signal in that metadata around good old-fashioned earnings events.
So to distinguish, so that is a form of metadata, but that may not, so I'm thinking of a more abstract level beyond that. In other words, metadata that would not contain any contentful.
I do understand what you're saying. That's the best I can do.
Okay, no problem. I mean, that's an answer to the question.
It's an answer, yes.
And, Stuart, I have one other follow-up question to you, which is, are you born in the same region as Michael Caine?
Michael Caine.
If I was brave, I would do my best Michael Caine, but I'm not going to do that. I do a really mean Sean Connery as well, by the way. That's a slightly different region. But don't get me going, please, because it could end badly.
Well, we have a question right here with the mic.
Steve, you mentioned earlier that now we are at a point where compute power is way more, and it has advanced over the last 20 years. Rahul, you also mentioned that the amount of data has grown, but then the storage is becoming that much easier to manage and all that, throwing on-demand computing to the cloud and all that as well. Everything is getting towards how we can use a lot of data and a lot of analytics power and so on and so forth for AI's use. Still, do you believe that the cost of implementing AI and using AI outweighs returns that you get out of it?
I think you have to be incentivized. You have to be incentivized, right, for that to be worthwhile.
Yeah, there was one of the examples earlier that a lot of credit card companies were okay, with the fraud because trying to do fraud prevention was a lot more expensive than actually paying outright, something like that.
Yeah, I think it's a spectrum between where AI technology has gotten commercial and has a commercial application already in place today, and sort of how do you continue to extend that, and to the other end of the spectrum where it is highly research oriented and sort of cost of development is still unknown, right? And I think it's along that spectrum. I'm sure there are applications today that are using well-known AI techniques that are in the commercial domain and are readily available. I mean, with what Google's done with its TensorFlow app, AI sort of intelligence service, they've kind of open sourced it now, right? So a lot of people are developing on the platform. And I think you're going to go through the spectrum where over time, certain things are just going to be commercially readily available and AI applications will be developed in that space, and you'll see services that very much employ them. And I think to the other end of the spectrum, it's going to fuel even more research to make it more commercially cheaply available.
I guess as it matures, I suppose it's gonna bring the cost down. They'll probably be off the rack products a little bit more often.
Yeah, I think there's the gentleman over there.
Yep. Okay. Oh, go ahead. Take it.
Yeah. Hi. So I grew up in the era of the Terminator and associating artificial intelligence to robots and SkyGrid. Can you tell us a little bit about the threats of artificial intelligence in finance? What can it do to our system that perhaps we're not prepared for? Or where do you see it being the most threatening when you have computers or machines autonomously making decisions?
I'm just going to jump in on that because we've had issues in the recent past which were hash crash. Everybody remembers that. There was some tweet that was read about the White House being attacked, and all of a sudden the market just dropped for about a minute and a half or something like that. Well, there are ghosts in the machine, and someone writes a program and there's a bug and they let it loose. That's a problem, and that will continue to be a problem. If there are other machines out there that recognize that that's, can I say black swan in this case, or something like that, some kind of irregularity in the market. Hopefully, there's a fail-safe. I remember when I was trading, I had my algorithm going. If something was off, I would just shut down because I could not foresee what was going to happen next or why certain markets are going in that way. So I guess you also need a fail-safe. If any, you want to go ahead and take that?
Yeah, I mean, so overall, I think systematic trading systems tend to have a net stabilizing effect on the market. And I'm sure a lot of people in the room will agree with me when I say that a lot of people have looked at some form of mean reversion of some kind at some point in their life, or fit something to an Ornstein-Uhlenbeck process or something. Well, if you've ever done that, then you're creating a system that tends to try to take the market back into equilibrium. Indeed, a lot of our investment philosophy is around the idea that prices get out of equilibrium. That creates an opportunity for clever investors to place a trade, which then has the effect of pushing the prices closer to equilibrium with respect to some notion of value based on some fundamentals. So, I mean, on the other side of the coin, clearly there are these momentary lapses where someone has written some terrible thing that is capable of essentially placing a very large order, large enough to move the market noticeably, at least temporarily, based on a single tweet or something like that. But I think there's a kind of a natural evolution in the market where systems like that tend to lose money and get shut down, and systems that are kind of driving prices back to a truer notion of equilibrium tend to succeed in the long run. And
I guess there's some extent of Darwinism in the market in that case. Another question? We have one all the way down there.
I have a question over here.
Oh, okay. Go ahead.
You've been talking about examples where there may be a way to stop something before a disaster happens. And usually the disaster is coming about in fractions of nanoseconds. Now, there are some examples of AI that are currently being funded to be developed that are taking a longer time to develop that may ultimately poorly affect all of us. Like if no other reason, there's not supposed to be an average human anywhere. Nevertheless, there are at least a couple physicians that are being paid good amounts to develop an AI application that will in fact do the prediction of what is wrong with the individual. It will be coming up with a computer-generated diagnosis. Just thinking about when I buy something online, and the next thing that pops up says that you may be interested in this also, and how badly they miss on that. I hope I'm never subject to that diagnosis. Is there some way to protect ourselves from all of this? Because that clearly would save money, and that will be funded.
It will, but I think there's checks and balances that have to be involved in that. You know, it's as Gordon does, he oversees the portfolios and the strategy over where he is, and he's going to make sure as well that these are performing correctly. You know, everything works until it doesn't, but as long as you're on top of it and you know, able to react, you still have, you know, billions of more neurons in your head than the computers do. At least you have the ability to be smart. Now, what's funny is the question once was asked to me about a year ago. I'm a big student of market structure, and when there are issues on the floor of the different exchanges and the market's tanking, it's usually companies like the New York Stock Exchange. I hate to say it, but there's people down there, and they know when to back away and not to go and execute because they see what's happening and they can react and avoid all the misinformation that's coming from the various systems that are out there. But that is an important question, and who's going to monitor this and who's going to make sure that it's right. So you might get a diagnosis over a machine of what's wrong with you, but you're not going to take that at rote. You'll say, okay, let's talk to somebody also. I want to talk to a doctor that. Yeah, I see that. I guess it depends on, you know, I hate to say it, but I guess it depends on where you are in the food chain of individuals, I suppose, on whether you have to rely on that or not. Correct? Do you want to jump in on any thoughts on that?
I think it comes back to, you know, what is AI really good at, right? There are certain things it's really, really great at. You know, it's really great at recognizing zip codes and recognizing a cat in an image. You know, and it can do that a lot faster and probably ultimately more accurately than we could, right? I mean, if you had humans look at 1 million envelopes and read off the zip code, they'd probably make a certain number of errors. The machine would make less. I mean, in the medical sense, you know, I think, you know, could a machine be good at that? Well, certainly not, you know, by itself. Certainly not to replace humans. But on the other hand, what are humans not good at? I mean, humans are not particularly good at keeping a database in their head of millions of diseases and millions of cures, you know, and cross-referencing them in their head in a second. So, you know, in that sense, could a computer do that better than a human? Sure. And, you know, maybe it reminds the doctor of something he learned in medical school, you know, 10 years ago and almost forgot. And then he says, ah, yes, you know, I remember now. I mean, I think that's the kind of thing it could be helpful.
More as a tool than the answer.
And I think you've got to take a more pragmatic approach to it. I mean, AI is meant to assist humans and not sort of replace them. I think that's sort of, you know, to the question Armando posed earlier, I think that sort of, you know, if you're going to go back and take a Terminator view to it, I don't think that's the right approach. I think this is all about how do you bring in optimization and efficiency to the problem as opposed to a replacement value to the problem.
We had another question back on the side there.
We've had several examples, in fact, the standard examples, in terms of the successes of AI in terms of image processing, speech processing, et cetera, et cetera, et cetera. The one thing that bothers me about that is all the examples I would consider games against nature. In other words, the other system is not reacting. People don't change their handwriting as a result of an AI system being able to read their handwriting. Markets, by their nature, they're games against people or games against competitors. And so if you build a strategy, and it's successful, there's probably somebody out there building another strategy that gets rid of your success. And I'm just interested in terms of what the panel has to say about this. Is this relevant? Is this irrelevant? Because, I mean, one possibility is that, again, we're ready to go in another one of these swings where AI is very popular, and then all the advantages washed away. or the competition. It'll require the next generation of AI.
I think the question is massively relevant, the successful managers are adapting to a change in the environment, which is measured by market data coming in every, I'm not sure about nanosecond, but coming in very frequently, very often. And certainly, what I was talking about earlier in adaptive algos, that's exactly what that's doing. It's saying, here's my essentially best guess on which algo to use now with this parameterization set based on all this historical research I've done, and I hope the history repeats itself, which it never does, of course. So therefore, by definition, it has to adapt to what the state is now versus what I thought it was, or it would have been. So the very nature of an adaptive algo is exactly responding to a situation which you can't predict by definition. So, and that's not, I think that probably the AI sort of does conjure up the sort of robots in a sort of thought process, but often these are just very, almost small techniques to help implement something that is very tractable at a human level. So I think using these techniques to help parameterize dynamically or on the fly, in flight, call it what you will, an execution algo is a very good example of that changing state that you didn't predict.
I think, it brings me back to understanding, just the beginning of trading in general, is understanding that each security is relatively its own animal. It has its own, responses, its own reactions to other market forces, and et cetera. And that's what AI will help us decide when we're putting out a portfolio and deciding to interact with the markets in a certain way, right? So, mentioning, as Elliot said, I think it is, it's definitely a relevant question. I think what we have here is it's still reactionary, but it's just that much faster than current capabilities. So,
one more.
Good.
One more question.
Where am I looking? Oh, okay.
Hi. Just following up on that, I think you said the AI techniques will adapt as the market changes. But if it becomes very prevalent and everybody's writing adaptive algos, then isn't that going to affect their performance?
Probably and possibly. But the great thing about finance and technology is stuff happens, it changes, and you adapt. The people, you have to. That's the great thing about this industry, actually, I think, is that, yes, if there's a steady state coming, then the people who get ahead of that or recognize that earlier will do something differently.
Right.
I don't see that as a problem.
Yeah, so if you have competing strategy with someone else in the market, well, you're going to notice there's erosion in your returns, and you're going to have to adapt, exactly what Stuart was saying, to that. Okay, I see we only have a few more minutes. Let's take two more questions, or one more question. Okay. Any more questions? No? Okay, so I guess I'll just wrap it up. Does anybody else want to make a final comment? Or just let me, all right, I'll take it from here. All right, great. So today we discussed topics of pragmatism versus practicality, deep learning, real-time learning, machine learning, the ultimate strengths and adaptability of these advanced methods. I wanted to get a little bit more into academia and policy, but I guess we'll leave that for another discussion. We even discussed AI's use in driverless cars and credit card fraud detection. However, we know we're just touching the surface of the exquisite and attractive opportunities that AI can bring to us. As long as it follows, I guess, as someone alluded before, we were talking about Terminator. I was thinking more about Asimov, as I sort of mentioned. He has these 3 rules of robotics: just don't hurt man, don't hurt man, don't hurt man, and if any other rules conflict with that, then don't do anything, right? So I guess the main topic is really make sure that it works, make sure that no harm comes from it. I'd like to thank my panelists for being here, and the questions you asked were fantastic, and I appreciate that very much, and I'm sure we all do. Thank you.